Hello, my name is Musharraf Zaman. I am a professor in civil engineering and environmental science and a professor in petroleum and geological engineering at OU. I serve as the director of Southern Plains Transportation Center, or SPTC, which is one of 10 regional university transportation centers in the country, funded by the U.S. Department of Transportation. The SPTC consortium is led by the University of Oklahoma and has at least one major university from each state in Region 6, which includes Oklahoma, Texas, New Mexico, Arkansas, and Louisiana. Our transportation facilities include roads, bridges, tunnels, rails, airports, waterways, and ports. These facilities are uniquely vulnerable to damages caused by severe storms, rising sea levels, storm surge, drought, and extreme temperatures. Nuisance flooding caused by tides and sea level rise is already affecting coastal communities. For example, Miami Beach is already rebuilding its transportation infrastructure to raise streets near the coast and install pumps and water mains. Their city effort to keep their streets dry is estimated to cost $400 to $500 million. Vulnerabilities and disruptions in the transportation sector will become more pronounced as the frequency of these extreme weather events become more frequent. Although there is limited availability of national estimates of motor vehicle fatalities attributable to adverse weather, one report estimates that 24% of all crashes in the United States from 1995 to 2005 were weather-related, with an associated annual average of 7,400 deaths and 673,000 injuries. According to another study, the combination of adverse weather and poor pavement conditions contributed to 18% of fatal crashes and 22% of injury crashes annually in the United States. When the SPTC was formed in 2013, Region 6 was experiencing a historic drought that severely impacted transportation and freight infrastructure. Between 2011 and 2012, drought caused more than $7 billion in damages to transportation infrastructure in Texas and Oklahoma alone. Following this disaster, this region experienced extensive rainfall and flooding, with major disruptions to infrastructure in the spring and early summer of 2015. Heavy rains in June that year led to rock slides in the Arbuckle Mountains in south-central Oklahoma, dumping 14,000 tons of debris on I-35 near Turner Falls. The Oklahoma Department of Transportation spent $1.6 million in debris removal and emergency repairs. When we look at the 10 states with the greatest number of FEMA-related disasters, the 5 states in Region 6 account for more than 50% of these declared disasters. Worldwide, transportation infrastructure is at risk in a changing climate. Intense rainfall events can scour bridges and erode embankments. High temperatures can cause the expansion of roadways, stress on joints, and buckling of railroad tracks. Because high temperatures are related to lower density air, airplanes that carry heavy fuel loads, such as for cross-country or international flights, may not be able to take off during extreme heat events. Worker safety is also compromised during extremely hot days, which reduces the ability of transportation agencies to maintain their infrastructure. In Alaska and other cold climates, transportation infrastructure has been built on permafrost or permanently frozen ground. As temperatures rise and permafrost melts, roadways, railways, and landing strips all become compromised as the ground sinks below them. In Arctic seas, melting sea ice will allow for freight to be shipped through the Arctic Sea, reducing transportation costs but also possibly damaging the ocean environment. Also, coastlines, ports, harbors, and marinas will become flooded with sea level rise, and coastal storms may bring larger and more damaging storm surges. Many major international airports, such as New York's LaGuardia, are projected to be temporarily or permanently flooded in the future. Flooding will occur inland with heavy rainfall events, disrupting navigation on important waterways. Yet, there is some good news for many winter maintenance budgets for state transportation agencies. For many northern U.S. cities, winter maintenance of roadways during and after snowstorms is a larger percentage of the annual transportation budget. With future warming, more precipitation will fall as rain instead of ice or snow, especially during the fall and spring transition seasons. Projections indicate that by the end of the century, there will be fewer days with snow to deal with on many American highways and streets. To develop climate-resilient transportation infrastructure, transportation designers must devise innovative construction and maintenance measures that consider daily and long-term impacts of severe weather and climate extremes. Increased demand and limited resources pose a major challenge to state departments of transportation to make our transportation infrastructure climate resilient. For example, researchers are using data from an instrumented bridge and computer models to develop design and construction guidelines for bridges. These bridges are jointless and provide superior performance during extreme variations in temperatures and moisture, and they significantly reduce maintenance costs and increase service life. Blowing dust can pose serious threats to traffic safety. To mitigate these hazards, researchers are developing a modeling and monitoring system that highway safety managers can use to reduce the hazardous impacts of blowing dust storms across the highways of the southern plains. Approximately 25% of highway fatalities in the U.S. occur at or near curves in the road, where loss of pavement surface friction plays a key role. Accurately characterizing surface friction under varying weather conditions, including rain, snow, and ice, is necessary to enhance traffic safety. For example, researchers are using three-dimensional laser imaging technology to measure surface friction at vehicle speeds and varying weather conditions to help improve traffic safety. To address weather and climate-related concerns in the transportation sector, organizations like the Southern Plains Transportation Center, South Central Climate Science Center, Center for Intelligent Transportation Systems, and Transportation Safety Institute collaborate to bring the best ideas and diverse expertise to the table. Also, growing private sector funding and investment is important to our long-term success, particularly in applied research, training, and technology transfer. As climate and weather-related stresses pose increased risks to public safety and infrastructure investments, partnerships like these will become increasingly important. Transportation planners, engineers, and climate scientists must work together to build a more resilient and cost-effective transportation network that keeps people safe, no matter the weather.